Hi. Today we're going to learn how to predict the weather using Facebook's Prophet algorithm. The great thing about Prophet is you don't need to do any feature engineering. It automatically picks up trends and seasonality in the data. It can also predict multiple days or even years into the future. Let's get started. First, we'll load in and clean weather data. Then we'll make initial predictions using the Prophet library. Then we'll cross-validate those predictions across our whole dataset. And we'll end with how to make future predictions for the next year and beyond. Let's get started. We'll be using the Jupyter Lab IDE, but you can use any IDE that supports Jupyter notebooks. And we'll first want to install a few dependencies, which we can install with the %, which calls a Jupyter magic. And then we can just run pip install pandas, Prophet, as well as scikit-learn and plotly. So we'll go ahead and install these libraries. And once they're installed, we can go ahead and remove this cell. And then we're ready to actually start coding. The first thing we're going to want to do is import our data. We're going to be using data on local weather in New York City. I shared the link to this weather dataset in the description, and it's a CSV file. We'll talk more about the structure of the CSV file later, but make sure you have the file downloaded. And if you want to customize this to your own city, there's actually instructions in the code, which I shared the link to also in the description, where you can actually create your own dataset with your local weather. Then what I'm going to do is I'm going to go ahead and start importing the data. So to do that, I'm going to use the pandas library. So I'm first going to import the pandas library. And I'm going to import NumPy, which I won't need just yet, but I'll need it later on. NumPy is a Python package that enables you to work with arrays. Pandas is a Python package that lets you work with data frames. So Pandas is built on top of NumPy. Then I'm going to read in the weather data. So here we're going to use the read CSV method from Pandas. And we're going to read in our file, which I've saved as weather.csv. And we're going to say we want the index column to be the date. So Pandas data frames have an index, which is a unique identifier for each row. And we're basically saying use the date as the unique identifier for each row. So we can go ahead and run that. And then we can go ahead and take a look at weather. And we can see that we have weather data from 1970 all the way through a couple days ago. So the 17th of November, 2022. And that's 38,000 rows. You can also see that we have data from two locations mixed into this data frame. So there's data from LaGuardia Airport, which is one of the main airports in New York. There's also data from JFK Airport, which is another major airport in New York. So for each day, we actually have two different rows, one from each airport. And we can see there's a bunch of columns. So I'm not going to explain all of these columns because we're not going to be using all of them. But some of the important ones are PRCP is how much it rained that day. Snow is how much snow fell that day. And snow depth, so how much snow was on the ground. There's also a couple other columns we're going to use that show the maximum and minimum temperature for that day. All right. Now, once we've loaded in our weather data, we need to do a little bit of data cleaning. So you might have noticed all of these NAN values. This is actually missing data. So some of these columns just have a lot of missing data because the sensors maybe didn't work all the time properly or they didn't record data correctly. So there's a lot of missing values. And machine learning models usually cannot work with missing values. So we're going to get rid of a lot of these columns that just have a ton of missing values. So we're going to create a variable called null percentage, which is going to contain the percentage of null values that are in each column. So we're going to use the apply method to basically run a function across each column in our data frame. So it's going to go column by column and run a function. So we're going to apply that. And then we will add together how many times a null value occurs in that column. So what this is going to do is it's going to apply the isNull function to each column. it's going to return true if the value is null, false if it's not null. And the sum is going to count up how many times a null value occurs in each column. And then to get the percentage, we're just going to divide it by the number of rows in our data frame, which you can see over here. And weather.shape0 will just give us that number, 38,000. So that's null percentage. If we take a look at it, it gives us the percentage of null values in each column. So for some of these columns, you can see null values are over 90%. So those columns are pretty unusable in our analysis. And for some, it's actually really, really low. So snow depth has just a couple of null values. It's a very small fraction of a percentage. All right, so the next thing we're going to do is we're going to create a variable called valid columns. And basically what we're going to say is we only want the columns where the null percentage is below 5%. So we can look at weather.columns, which gives us a list of all of our column names. And we're going to say we only want the column names where null percentage is less than 5%. So let's go ahead and run that, and then we can take a look at valid columns. So these are the columns that have a null percentage less than 5. And these are the columns that I mentioned before, these 5. The next thing we're going to do is subset our weather data frame to only include our valid columns. So we're going to look at weather valid columns, and we're actually going to copy this. If you don't do this .copy, you can get a setting with copy warning later, which can be pretty annoying to debug. So this just makes sure that instead of pointing to the variables in memory, Pandas actually makes a fresh variable that contains only the valid columns. So we'll go ahead and run that, and we can take a look at weather, and we can see that we've removed all of the columns that have more than 5% null values. All right, and this is something I like to do. You don't have to do it if you don't want to, but I like to only have lowercase column names. It's kind of annoying to always hold shift or press caps lock when you're typing in column names. So I'm just going to do weather.columns.str.lower. So .str is the string accessor for each of the column names, and .lower will actually lowercase all of the columns, and then we'll assign it back to weather.columns. So we're basically taking these, turning them into lowercase, and assigning them back. So if we take a look at weather now, we'll see that all of the names are lowercase. And one more thing we need to do as part of our data cleaning is we want to make sure that our dates are actually stored properly as date times. Pandas can store values in a lot of different ways, as strings, as numbers, as dates. And if things are stored in the correct data type, it just makes them easier to work with later on. So in this case, our index is this date column right here, and it's actually stored as a string. So we're going to use the pandas toDateTime function to convert it into a datetime. And actually, I'll show you what it looks like before and after. So before I run that code, we'll take a look at weather.index. And you can see it's stored as an object, which is a string. Then I'll go ahead and run it, and we can take a look at weather.index again. And we can see now it's stored as a datetime, which makes a lot of things easier later on. All right, we noticed that we had data from multiple locations earlier. So right now I'm going to look at the column called station and look at the unique values in that column. So there are two columns that indicate where the data came from. There's the station ID, which is in the station column, and there's the name, which is just the full name that makes sense, right? These IDs don't make a lot of sense initially when we look at them. But we're just looking at the unique values. And what this lets us do is split the data up. So what we're going to try to do is forecast the maximum temperature at JFK each day. And we're going to use data from LaGuardia, LGA, to help us predict that. So what we're going to do is split the data frame up into two, one that has data for JFK Airport, one that has data for LaGuardia Airport, and then we're going to combine them so they fit together and add extra columns to each row. So then each row is going to have a unique date, and data from both stations will show up in a single row. Instead of right now, we have duplicate dates in our index and two observations for each day. So we're just going to reshape the data to make it easier to work with when we're doing our predictions. All right. So the first thing I'm going to do is I'm going to create a data frame called LGA for LaGuardia. And all this is going to be is all of the rows where the station ID equals this, USW 14732. That's the station ID for LaGuardia Airport. And I'm again going to do .copy. So if we look at LGA, this is only data for LaGuardia Airport now. And you can see the row count is about half of the original row count. And then what we'll do is we'll do the same thing for JFK, except we're going to keep this as the weather data frame, because what we're trying to predict is the maximum temperature at JFK each day. So we're just going to call this weather. And the ID for JFK is USW 94789. All right, so now we have two data frames, weather and LGA. One has data for JFK, one has data for LaGuardia. We're going to merge them together, as I mentioned. So they have the same number of rows, 19,000, but 14 columns, corresponding to data from both weather stations. So we can use the pandas merge method to do this. And if you're familiar with SQL, this works very similarly. So basically, we specify a column we want to merge on from our weather data frame and a column we want to merge on from our LGA data frame. In this case, it's the index in both, right? We want to merge based on date. So all of the observations from January 1st, 1970 go together. All of the observations from January 2nd go together, and so on. So we're going to say left index equals true, right index equals true, which means merge based on the index. And if we take a look at weather now, we can see that we have 14 columns and 19,000 rows. And if you look, you see that each row has data from both airports. And you can see that the columns have been renamed. So the columns for JFK now have _X at the end, and the columns for LaGuardia now have _Y at the end. Pandas does that automatically if they're duplicate column names when you're merging. All right, so that was a lot of data cleaning. We can now do the setup for Prophet and actually run our Prophet algorithm. So what we're going to do is we're going to set up the target, which is the thing we're trying to predict. And I mentioned what we're trying to predict is the future temperature at JFK Airport. So what we're going to do is we're going to say weather.shift -1 Tmax X. All right, so what's this going to do? So it's going to take this Tmax X column, which is the maximum daily temperature at JFK Airport, and it's going to shift it back 1 day. So let me just run it, and then I can show it to you so you can see what it looks like. And actually, let me just look at Tmax X and Y. All right, so we can see the Y is a pulled back version of Tmax X. So you can see that the maximum temperature X on January 2nd, 1970 was 31. And you can see that the Y value on January 1st is 31. So all of the values in this column have basically been pulled back 1 day and assigned to this column. And what does that tell us? So Y is now tomorrow's temperature. So that means we can use today's maximum temperature to help us forecast tomorrow's maximum temperature. So that's all Y is. Y is tomorrow's temperature. So for January 2nd, this is today's temperature, this is tomorrow's temperature, and the same thing for the rest of the days. All right, we're now going to fill in any missing values. So some of our earlier columns had null values, like snow depth had a couple, as we noticed before. And you'll notice there is a missing value here also. That's because we don't have data for November 18th, 2022. So there's nothing to actually pull back and use as tomorrow's temperature. So in this case, we're just going to forward fill, which means take the last non-null value in the column and use it to fill in the next null value. And that's what the ffill method does. It's forward fill. It doesn't make total sense to fill in this NaN value with yesterday's temperature, but keeping this in makes it easier to forecast the future, and it's not going to mess up our predictions, really. So That's why we're doing it there. All right, we can take a look at weather now. And there are now no missing values in our data frame. Okay, we're now ready for machine learning. So there's one other column we need to set up. So we set up the Y column as our target, and it actually needs to be called Y for profit to work. So don't rename this. We also need a column called DS, which is actually the date of each observation. So we're just going to assign weather.index to a column called DS. Profit needs it to be called DS. It won't work if the index is a date. So it just needs it to be in a very specific format. And we can see we have our Y and DS columns at the end of our data frame. All right. Then we're going to create a list of predictors. So predictors are all of the columns that we want to use to predict tomorrow's temperature. So we obviously don't want to use tomorrow's temperature to predict itself. We also can't use the station and the name because those are strings, and machine learning algorithms need to use numbers to predict other numbers. They can't use strings unless you convert them to numbers, but in this case, these columns only have 2 values, so they wouldn't really give the algorithm anything useful. So we're going to create what's called a list of predictors, and these are just the columns we're going to use to predict the Y column. And basically, we're just going to find all of the columns except the columns that are in this list. So is_in will basically check to see if a set of values is in another set of values. So we're going to take basically all of the columns except for Y, name X, station X, name Y. Name Y is the name for LaGuardia. Station Y, and the DS column, which just duplicates the index. All right, so these are all of our predictors. And if we take a look at predictors, we'll see that this is basically all of our columns, except the ones I just put in this list. So these are the columns we're going to use to predict tomorrow's temperature. Then we can split our data up into 2 sets, a training set that we use to train our algorithm and a test set that we use to evaluate how well our algorithm did. So I'm going to go ahead and create our training set. And just for this first time we run the algorithm, I'm going to keep this really simple. I'm basically going to take all of the data from 1970 up through the end of 2021 and put that into our training set. And then for our test set, I'm going to take everything in 2022. So everything from 2021, 12/31 onwards. All right, now we can do the fun part. So we can use Prophet to actually make some predictions. All right, so that's our train and test set. And then what we can do is we can say from Prophet, import Prophet. So from the library called Prophet, we're importing a class called Prophet, which will actually do the predictions for us. And we're going to create a little function called fitProphet, which will take in our training data set. We'll first initialize our Prophet class, just using an empty constructor. We'll assign it to a variable called m. And then we'll loop through our predictors. And we're going to add these predictors as additional regressors. So what these additional regressors do is they help us predict our Y, which is tomorrow's temperature. And basically, we're going to add in all of these columns as additional regressors. And then we're going to fit our Prophet model to our training data. And then at the end, we'll return our fitProphet model. So we can call this function by saying m equals fitProphet train. So let's go ahead and run this. This will take just a second to fully run. And you'll get a couple of warning messages. Don't worry about this. Nothing's going wrong or anything. There's just a library that Prophet calls that is very noisy and has a lot of log messages. It's called stan. All right, so we fit our model. Now we can make predictions. And we do that by saying m.predict, and we're going to generate the predictions on our test set. And we can take a look at our predictions. All right, and our predictions have a bunch of different columns. The most important column is the one at the end, y hat. That's actually our predicted tomorrow's temperature. So for each day in 2022 and the last day of 2021, we have a predicted future temperature. All right. So what Prophet does is it basically does time series forecasting. So it picks out a lot of different components from the time series and tries to model how that time series will change. So we can look more deeply at what Prophet is doing by plotting the different components that go into Prophet's predictions. So I'm going to go ahead and do an import. So I'm going to say from prophet.plot, import plotly, plot components plotly, and plot cross-validation metric. So some of these we won't need until later, but I'm just going to import all three for now. So what we're going to say is plot components plotly. We're going to pass in M, which is our Prophet class, and we're going to pass in predictions. And this will make a nice plot, and I'm going to explain what this plot means. So trend is the general trend in temperature over time. So basically, Prophet separates out your time series into several different components. And actually, to visualize the time series, let me just go ahead and do that. So we can say weather.plot, and we can pass in our Y column. That is not, okay, let's pass in DS and Y. It should work. Yeah, so we can see this is our temperature over time. And actually, let me just get a subset of this so it's a little more obvious what's happening. Let me look from 2018, 0101 to present. Okay, so this is going to plot our temperatures from 2018 through 2022 through the present. And you can see there's a strong pattern in our daily temperatures, right? So during the summer, which is where these peaks are, temperature is high. During the winter, where the troughs are, the bottoms of these graphs, the temperature is low. And this pattern repeats over time, right? So this is essentially called a seasonal pattern. In certain seasons, the temperature is high. In other seasons, the temperature is low. Now, what Prophet does is it separates out the time series into these different factors. Like how much does the month impact the temperature? How much does the day of week impact the temperature? Is there a general trend in the temperature separate from those seasonal effects? And it tries to predict each one separately and then add them together to get the final prediction. So these components are basically separating out the different pieces that Prophet uses to make its prediction. So it's looking at the trend, which is just a general trend in the temperatures. It's looking at the extra regressors. So these are all the extra columns that we added, like precipitation, etc. And this is how much they impact our prediction. This is the annual trend in temperature. You can see it peaks in July, August, September. And this is the day of week trend in temperature. I'm not sure if this is an actual trend or if Prophet just picked something up that's noise. I don't know if Wednesdays are actually colder generally in New York. They might be, but I don't think they are. But you can see how Prophet is making its choices about predictions. It's basically separating it out into a bunch of different prediction problems and adding the results together. Okay, so we have our plot. Now what we can do is we can look at how important each of our columns are to Prophet's predictions. So we're going to say from prophet.utilities, import regressor coefficients. And then we can run the regressor coefficients function on our trained Prophet model. And this shows each row is basically the impact of a single regressor on our prediction. So this first row shows us the impact of the precipitation at JFK on tomorrow's temperature. And you can see generally if it rained today, Prophet thinks that tomorrow the temperature will be lower if it rained today. So that is indicated by a negative coefficient. Same thing with snow and snow depth, although snow depth it has a slight positive, which is interesting. You can see similar coefficients for these other variables as well. So this tells you a little bit about how Prophet is making its judgments as well. All right. Now we can look at what's called mean squared error, which is a very common way to measure how effective the model was. So we're going to go ahead and match our predictions index to our test index. And then we're going to create a column called actual in our predictions that has our actual values from our test set. And then we can write a little function called mean squared error that takes in our predictions. It takes in a label for our actual values, and it takes in a label for our predictive values, which is y hat in profit. Y hat is the prediction, as we saw earlier. Then we're going to calculate our standard error, our squared error, which is going to be predictions, actual label, minus predictions, pred label. So all we're doing here is we're subtracting our predictions from our actuals, and we're squaring. And that's going to give us an error metric. And then we'll print the mean of this error metric, which will give us mean squared error. And then we can call our mean squared error function on our predictions. And this tells us that our mean squared error is about 40. So just as a baseline, when I trained a machine learning model with manual feature engineering, which is basically telling the model which features are important and creating ratios, I got to about a 36 mean squared error. And then when I used deep learning got to about a 52 mean squared error. So this model is pretty good for not doing any feature engineering, not doing anything else. So Prophet is pretty powerful. What we're going to do next is we're actually going to evaluate the Prophet model across our entire data set. So here we just got mean squared error for 2022, but something could be weird about 2022 with temperatures, and our model could actually be better than we think it is. So if we evaluate it across our whole data set using something called cross-validation, we can get a more realistic error estimate. So what I'm going to do is I'm going to say from prophet.diagnostics import cross-validation. So what cross-validation does is it splits our data up into multiple pieces, and then it uses the first piece, for example, to predict the second piece. Then it puts the first and second pieces together, uses it to predict the third piece. And what this makes sure is you're not training your model using the same data you're testing it on, but you're still able to get an error metric or estimate across a good portion of your data. So I'm again going to call the fit prophet function, but this time I'm going to pass in the entire weather data frame. And then we are going to call cross-validation on our prophet instance. And we're going to pass in a variable called initial. And initial is going to be how many initial days of training data we want before we start making predictions. And I'm going to call this 5 years of data. Then we're going to specify a period. So a period is how often we want to train a new model. So we're going to say every 180 days. And then how many days we want to make predictions for, which is again 180 days. So every half year, we're going to train a new model and we're going to make predictions starting from 1975. So we're going to make predictions for every 6 months from 1975 onwards. And we're going to say parallel equals processes, which means we're going to parallelize this method across multiple processes, which will make it run a little bit faster. So let me go ahead and run this. And it's going to take a little bit to run. All right, so our cross-validation has finished. And the next thing we can do is we can use our mean squared error function, pass in our cross-validated results, and pass in our actual label, which is y, to actually get a mean squared error. And our error across our whole data set is actually a little bit lower than our error just for 2022. So maybe there was something a little bit weird happening in 2022. Our model, in general, we can say that this is our general purpose mean squared error. And we can take a look at our y and our y hat values and plot them. So let's take a look at y hat, and we'll take a look at just the last 365 days, and we'll plot this using the pandas plot method. Negative 365 up to. And we can see this is our actual y value, and we can see our predicted y value as well. So our predicted Y value does correlate pretty well and follow the trend pretty well. But you can see there are a lot of spikes in the actual temperature that our model just doesn't know about, right? Those spikes could be for a lot of reasons. There could be a storm system coming south from Canada into New York. There could be a hurricane, right? And our model just doesn't have enough information to follow all of the spikes, essentially. All right. Now what we can do is we can use this model to predict 1 day ahead. So we can again call fit profit, and we'll pass in our weather data frame. And then we can call predict, and basically just predict on our last row in our data. And what this is going to do is give us predictions for tomorrow. We can't predict using this exact technique. I'll show you another technique that we can use to predict multiple days ahead. But given this exact technique, we can only predict 1 day ahead because we need to pass in all of these regressors like snow depth, snow, etc. And we only know those 1 day prior to our prediction. All right, so this would be our prediction for the temperature on the 18th, which is the next day. So we're predicting that it would be 50 degrees. So this prediction is going to be pretty accurate, but we can only do it 1 day ahead. Let me show you another way we can predict that is less accurate, but can predict multiple days ahead. So we'll first initialize profit, then we'll fit it using our entire weather data set. Then what we'll do is we'll call the make future data frame method to basically create dates for the next 365 days. So for the next year. So that's going to be a data frame called future. Let me show you future. It's pretty straightforward. It just has one column called DS, and it has dates into the future. So you see 2023 dates here. And then what we'll say is we'll say forecast equals m.predict future. And then what we can do is we can plot using Plotly and that import from before our forecast. This might take a second, but this will plot predictions for a full year ahead. These are going to be less accurate because they don't use all of our regressors, but they enable us to make predictions multiple days ahead, even a year ahead. Okay, so the black dots are the actual values, and the blue line is the predicted values. So you can see we don't have actual values beyond the present day, but these are our predicted values up to a year ahead for maximum temperature. And you could do this for multiple years also if you wanted to. So it's going to be less accurate the further out you go, but this same technique you can use to predict pretty far in advance. Okay, so here what we learned was how to load in weather data. And in the README, there's a way to actually generate this data for your local area. So you could even use your local weather to predict. We cleaned our data up. We got it ready for machine learning. Then we actually trained our first profit model to make predictions. We figured out our error. We showed how the different components feed into our predictions. We calculated our error, and then we did cross-validation across our whole data set to find basically a more accurate error metric. And then we made predictions for the future. One way that's more accurate, but can only do 1 day in advance, and another way that's less accurate, but can do many, many days in advance.